Address Resolution Protocol is a powerful protocol on our networks that allow our networks to function. With ARP, we're talking about having a known IP address being mapped to an unknown MAC address. And this is being used all the time with our devices on the network. Now, a client can send an unsolicited ARP reply, which is known as a gratuitous ARP. It's really a broadcast that we have a specific IP address that is mapped to a specific MAC address. Now, the problem is when someone sends out a gratuitous ARP as a broadcast, other devices, which should be hosts as well as network switches, are going to store that MAC address and IP address combo in their ARP tables and MAC address tables. This is an issue because a threat actor can send a gratuitous ARP message with spoofed information inside of it. This effectively allows any host to claim to be the owner of any IP address and MAC address combo that they want to. So let's talk about it. Here in our graphic, we've got PC1, PC2, and R1. They all have ARP caches that are up to date and correct. But what's going to happen here is PC2, the threat actor, is going to send out a gratuitous ARP. And that gratuitous ARP is going to claim that 10.0.0.1, the IP address of the router, is reachable by using MAC address all Cs, which is the MAC address of the threat actor. Also, the threat actor PC2 sends out a gratuitous ARP claiming that 10.0.0.11, which is the IP address of PC1, is reachable with MAC address all Cs, which is again the attacker. So what's going to happen here is when PC1 sends data to the 10.0.0.1 IP address, it'll be sending it at layer 2 to the attacker, which is all Cs. When the attacker receives this data, it'll be using it as a man-in-the-middle attack. When the router responds to 10.0.0.11, the router will be responding to the layer 2 target, the MAC address of all Cs, which again is going to be the threat actor. So what it comes down to is exactly this. PC1 will want to send data to 10.0.0.1, and to do so, it'll send it to the MAC address of all Cs, which is PC2. PC2 forwards that data onto the router. The router will send it outbound to where it needs to go. As the router responds back to that 10.0.0.11 IP address, it'll be responding back, targeting all Cs, again the MAC address of the threat actor. This is a beautiful man-in-the-middle attack. Spanning tree is a protocol that is on by default on our Cisco switches. Its job is to provide us redundant connections while maintaining loop-free pathways, and it does it great. But the problem is threat actors can utilize spanning tree to actually change the topology of your network infrastructure. Now, the way they would do this is based off of logical, not based off of physical connections, but they would make their host appear as a root bridge. To do this, they would be sending out bridge protocol data units, which are spanning tree layer 2 messages. And these messages will include a priority of something insanely low, such as 0, for example, here in our graphic. By sending out these spanning tree messages saying that their priority is insanely good, the network infrastructure will view that threat actor's host, which is pretending to be a switch, as the root bridge, and they will all find the best way to reach the root bridge, which means they'll be dropping their main connection between each other and connecting through that switch itself. This allows the threat actor machine to pretty much act as a man-in-the-middle style attack and to be able to see all network traffic moving across this network domain. Cisco Discovery Protocol is a Cisco proprietary Layer 2 link discovery protocol. This thing is amazing. It can be used to verify Layer 1 and Layer 2 connectivity. And the cool thing is it's on by default on all Cisco devices. Now, on that same point, it can be insanely scary that it's on by default on all devices because it's used to automatically discover other CDP-enabled devices that are directly connected. This can even be used to auto-configure some of their connections. Now, while CDP is extremely useful in network troubleshooting, our threat actors can use it to easily discover network infrastructure vulnerabilities. For example, the CDP information that's being sent out, it's being sent out periodically and as unencrypted broadcasts. This information that is periodically sent out and sent out in an unencrypted format includes the IP address of the Cisco device. It includes the Cisco Internet Networking Operating System version. It includes the platform and even based off of the capabilities of that model of the device. It even includes VLAN information and more. So here's a graphic that pulled off of a protocol analyzer showing a CDP message and ripping it apart in this unencrypted, unsafe protocol reaching out to our end devices. So how can we stop our end devices from receiving this periodic unencrypted CDP laden full of info of greatness? Well, 2 commands. We have no CDP run. No CDP run is put in the global config mode of your device, and that will turn off CDP everywhere on your Cisco device. Or you want to leave CDP on for those inter-network device connections between Cisco devices, but just off on the user interfaces. That would be the command no CDP enable. That's in interface config mode, and that's what you use on your interfaces connected down to end devices. We also have LLDP, which is Link Layer Discovery Protocol. It's a ventral neutral flavor of CDP. This is also vulnerable to recon attacks. We can turn this off globally in our global configuration mode using the no LLDP run command. As well as if you want to do interface specific commands, we can use no LLDP transmit and also no LLDP receive, respectively.